Just in Lua, everything is an object. There are no such things as classes. In Python, the situation is the same. It's just that in Python, you don't have to do the construction of the object, you don't have to do the inheritance set, and you don't have to set the index here, which is the inheritance part as well. So Python does those all automatically for you, priors in the init, priors that are being called. That's the difference between them. That's why this is part of the reason why I like this. Other questions?
Can you do the member variable after the local obj table?
Yes. You can also do. You can put this obj.temp anywhere after the local before the return.
All right, cool. That's okay.
Just gonna record real fast. Yeah. Study. Yeah.
Okay. Other questions?
When you talk about declarative and you say what you want, not how to get it, what do you mean by that?
The question you just asked. Do you know the steps to answer it? The answer is maybe, maybe not, right? What did you do though?
I asked the question.
You asked a question. And so what I'm going to do is I'm going to respond with the correct answer, even though you might not know the steps to achieving the correct answer. So they're very much black boxes. So let's actually let me give an example of a declarative language statement. A declarative language statement is SQL. I'm going to use SQL because it's most common. We can say something like this: select star from people where name equals Scott. That's a SQL statement. So this does not tell you how to get the information. It just tells you what information you want. So all you need to know when you're looking at this is that there's a database of people. There's a group of people, and they have names. Give me all of the people whose name is Scott, and this will return all people whose name are Scott. You don't have to say for every element inside of people, if people.name equals Scott, add to return list. At the end of the for loop, return list of people. You don't have to do any of those imperative steps. You say, I want this, give it to me.
Okay.
That's how declarative languages work. Because I know, like, even if there's 10,000 people here, these 10,000 people, I don't know how it gets it. I don't care either. It's kind of like when you go to Google and you say, hey Google, how do I X on Google? And Google says, here you go. Google's a natural language declarative programming environment, where the English is or whatever language you speak is the language that it responds.
So those paradigms can implement other ones too?
You can implement multiple paradigms at the same time.
Like we have imperative that does structure and it does not functional, not the other one, but
procedural and things like that, object-oriented, yeah. So most common ones are imperative, procedural, structured, object-oriented. Those are the most common paradigms. So typically when people say, I want to learn how to program, what they really mean to say is, I want to learn how to program an imperative, procedural, structured procedural language that might have object-oriented programming in it. That's really what they want to say. They don't know any of those words.
So functional is completely different?
Functional is completely different.
And when you say no side effects and no mutable variables,
yeah.
So that leads to independency, but like...
Correct. So like, for example, in Java, you say int x equals 3, and then later you can say int x equals 4. You can't do that in Haskell or in functional languages. Oh, that reminds me. Well, it's okay. Everybody will get it. Everybody will get it is what's going to happen to me. You can't do that in Haskell.
You can't?
You cannot.
Okay.
Because this is a variable x, and I just changed that variable x. You cannot change variables. Once they're assigned, it is forever that value.
But in Python you can.
But in Python you can, because Python is not functional. And so we talked about list comprehensions in Python. And list comprehensions in Python approximate functional languages, but they're not actually functional.
All right.
He's teaching Python. One of the things. All right, other questions?
I want to ask about the Lua constructor.
The Lua constructor? So you want me to do it again, or what I did is okay? You're good? Cool. No? Looks away. I don't know. Don't point at me.
How much Haskell are we going to need to know?
So Haskell, there's going to be no Haskell on the test. I think I said that a while ago.
Yeah.
So don't worry about that.
Do we need to, because I noticed that you use the pairs function in Python.
In
Do we
Lua?
need to yeah, like to access an array? Do we need to know, like, so because we didn't really work with that many functions from the languages, like pairs, and then like how to like add things to an array, things like that.
So so this goes into the not necessarily remembering exact syntax for languages, but for example, if you try to write a for loop in Lua, let's suppose a for loop in Lua that counts from say 1 to 100 looks like this, right? And I know that a for loop in Python that counts from 1 to 100 looks like this. And I know that a C one looks something like this. Like that. If you took that for loop and wrote that for loop in Lua, then that would be wrong. However, if you did something like this, which is wrong, but is close, that would be okay. If you wrote this in the Lua one, I would give you the credit for the for loop, but I would not give you the credit for the language. And so if you know the algorithm, but you don't know the language, you can still get partial credit. You actually get most of the credit. The language is less important. So for example, if you're like, oh, I don't know how to do all the pairs. Let's suppose you forgot about pairs in Lua, or you don't know about pairs in Lua. And you have some array A something that you don't know what it is. And you want to print all of those elements. If you say print A of I, that's fine. If you forget the pairs with the K and the D stuff. I'm not gonna significantly dock you for something like that.
While we roll it, it's been like the turn the bash.
None of those words made sense. Say it again.
I'm just very sleepy, but what if you roll it in terms of bash, that for example, like you wrote for F and files, print blah blah blah, would that work too? Would that count?
So it depends on what the question is. I'm not going to ask you any bash questions specifically, but if you did do something like that, it's actually not that bad. Like so, for F in files like that, it works in bash. You'll notice it's actually very similar to Python for I in range.
Yeah.
And so if you're doing that if you write something like that in Lua or Python, I would give it to you. If you tried that in C, however, I would not.
Okay, gotcha.
Because C does not accept
Yeah,
that.
C does.
Right?
Yeah.
And so that's one of those limitations. And so if you recognize that, if you say, I want to do this, but I don't know how to do it in C, you'll get credit for the concept, but you won't get credit for the language.
Okay.
Cool?
But that does work in Lua. Lua and Python, though, right?
Huh? So it's almost correct in Lua. In Lua, it would be something like this. I think it's for F. You can't do it exactly like that. You have to do something like this. For F in pairs, F comma K comma F actually. Sorry, K comma F in pairs on files. In Lua. You could do it in Python, but in Lua you can't. And if you don't remember this, 2 points out of 300.
So what is the pairs things do?
Pairs returns both the key, which is the index,
Yeah.
and the value. Because in Lua, the key does not have to be a number. Right? So like for example, when we think about things in C, we want to say A of 1 equals some value. That's cool. In Lua, we can also say A of hello equals some value, which is also fine in Lua. How do you get that hello key out? And that's what the pairs does for you. Yeah.
What languages should we start
C, Lua, Python. I didn't cover it too much in class, so I'm not going to ask you a C++ specific question.
I thought you said you were not going to ask us to write on C either.
You should know C enough to the point that you'll be able to know when it's wrong. Let's put it that way.
Okay, okay.
You won't have to write in C.
Okay, yeah, that's
Does
what
that
you
answer
said.
your question?
You won't. You just said that we were not gonna write in C.
Yeah.
Yeah.
Is that better? Try not to give away too many things. It's hard when people ask the best questions. Like I had last semester, somebody came in and they just asked a question off the midterm. I was like, well, I'll just answer it because they didn't know. They showed up the next day. They're like,
how are we doing so far?
Holy shit!
Okay.
We're getting close.
Tokenization is when strings are separated into pieces, and then use a delimiter to see where you want to separate it.
Correct.
What is parse?
What is parsing?
Yeah, parsing. Because
So-
I'm reading this paper, the study guide thing,
So you have parsing, which is the second step. So you have tokenization, right? Which leads into parsing. What's the other name that we have for parsing? Maybe that'll help you.
CFG.
CFG.
CFG?
Yeah, CFG. CFG stands for context-free grammar.
Oh, yeah, that's it. Okay.
Right? So parsing is really the context-free grammar step. The context-free grammar step is the determination if the sentence is grammatically correct or not.
What does that mean?
That means, is the sentence grammatically correct or not? That's what it means. It means without knowledge of if the sentence is semantically valid, if the sentence is grammatically valid. So for example, depending upon the language that you're in, let's use spoken language, because spoken language or natural human language is easier to do. For example, if I told you that I had a noun, right, followed by a verb, followed by a noun, this could be a valid sentence, correct? For example, Scott kicks the ball.
Yes.
Right? That's a valid sentence. The fact that there's an article in there, whatever. Who cares? Right? Scott kicks the ball. If I asked you about that in Japanese, could you have a noun, verb, noun? In Japanese, the answer is no. What about in Spanish? Can you do that in Spanish? Can you not do that in Spanish?
Yeah.
Yeah, you can do that in Spanish, right? Yeah, okay. Somebody said no. I was like, what? Good. Spanish isn't that different. So for example, this is a subject, this is the verb, and this is the object. So English, Spanish, subject, verb, object languages. Japanese, for example, is not a subject, verb, object. It's a subject, object, verb language, and usually it's only an object, verb language. They don't purpose subject. Vietnamese is also different, correct? No, it's subject, verb, object? Okay. Is Chinese? I don't know if anybody speaks. Do you guys speak Chinese? No? You don't know? I know that you're not Chinese. I was just wondering if you knew.
Japanese is what?
Huh?
Japanese is what kind of language?
It's a subject, object, verb. And so it would be Scott, the ball kicks. And usually it'd only be the ball kicks is the only thing you'd say. You wouldn't actually ever say Scott.
That's kind of like sign language.
Yeah, it's different. And so we know that the language is different regardless of whether these things make any sense. So for example, I could have in here, I could say Scott flies the cat. Does that make conceptual sense?
Yeah.
What does that mean? Scott flies the cat. That would be throw. Right? Scott throws the cat. I don't throw cats. I'm allergic to them, but I don't throw them. Flies
It
the
could be the
cat.
name of a kite.
Ah, yeah, that's a good one.
It could be the name of a jet. Or it could be the name of a plane.
How about
Caterpillar does a lot.
what's a sentence that really doesn't make any sense?
Scott poops balls.
So that's another thing that can be real. Just totally not okay. I don't know, but you can see how there's sentences that don't make sense.
Yeah, like if you pick a plant.
Yeah, Scott stole your kidney. Right? It might be true, but it really isn't. So for example, in programming languages, we say something like at x equals 3. That's a grammatically correct sentence. It's also conceptually valid, which happens to be good. However, if I did something like this, int x equals 3.14, that is not a grammatically correct sentence, because I cannot grammatically assign a float to an integer. And so your compiler yells at you unless you cast that, or at least it raises a warning. And so this is what context-free grammars do. Context-free grammars are able to differentiate between the fact that this is an integer, a variable, and an integer variable, and this is an integer variable with a float with an assignment in the middle.
So whenever you're parsing, you're just checking to make sure that your syntax is correct.
That your grammar is correct. Yeah. Sorry.
Backstep 2.4.
Yeah.
Is there any language where that would just shoot out a 3?
So yes, it depends upon your compiler flags. You can actually set your compiler in C to just make it a 3.
Just in C?
Mm-hmm. C++ as well, Java. There's every language you can tell it to shut up. Most languages with compilers, there's a compiler flag in there. You say shut up, turn that off, and your compiler won't tell you about it anymore, and then your program's wrong.
Right above that line, if you were to say x equals 1 before it's declared, would that be an error grammatically or just an error of the language?
So I don't know. I don't know the answer to that specifically for C and Java and things like that. We could make this a grammatical error because there's different layers. There's different kinds of grammar. We can have sentence-based grammar and story-based grammar, right? And so when we say story-based grammar, we mean sentences in a row. I don't know whether or not the sentences in a row are done by story or whether or not it's something else entirely.
So
I imagine that it's probably done with the same thing. Yeah.
Cool. Okay.
Yeah. They use something called state diagrams to actually figure this out. This part, I know for certain that they do use state diagrams. I don't know if they call it grammar or not. Other questions? More stuff. Yeah.
Can you go over how to do object-oriented programming in C? Or mimic it?
In C, how to fake it?
Yeah.
Okay. So when we look at C, so for example, I have a function in C. Let's make a function int get value. I'm going to make this take, I don't know the argument type yet, but I'm going to make this take an A is going to be the name of the variable. And this is a get value function, which means that it's supposed to be getting, let's say it's a getter, which is common in Java and things like that, like get temp, get value, get whatever the name of the argument is, or the name of the member variable. So let's suppose that there's a member variable called value inside of the A thing. I can say something like this, return a.value. And at first we go, that doesn't make any sense to us because C doesn't have objects, right? But is there a way that I can do this?
With structs.
We can do it with structs. So for example, if I have a struct, if I say struct, let's call this thermostat. Thermostats can have a value, an integer value inside it. Let's call it the integer value. An integer value inside of them, right? So then this parameter here, which is the first parameter, can be that struct therm. So now I have a function that operates on pieces of data. So now if I have inside of my main, let's say I have a main somewhere. If I say struct therm, let's not say A, let's call this O for object. That'll construct a new struct therm on the stack. I can then say something like O dot value equals 3. And then if I call get value on O, that will return A dot value or O dot value. If I look at this portion here, this portion here should look familiar as far as object-oriented programming goes. It's not quite at that point yet, but how does this part look familiar as object-oriented programming?
Getters and setters.
You have getters and setters, but it's a little bit farther even than that. A little bit more in depth.
It's not a part of a class.
So we'll get there, but that's not the reason why it's not like an object-oriented. Why is it like an object-oriented currently?
It doesn't take in a primitive data type.
So it doesn't take in a primitive data type. That's part of it, but it's more specific than that. So this non-primitive data type here, A, right? Well, what if I chose to rename that to a different variable? What would be a better object-oriented programming name instead of A? What should I call that instead? Anybody got an idea?
Maybe a city.
Huh?
A city.
Nah.
No.
A better object-oriented programming name for member functions.
Like temp, like temperature, no?
Object.
What variable do all member functions get?
Self. No.
Self or
This.
this?
That's right.
Either one of those are accepted. Which one do you want to use?
Yes.
This? So I'm going to call this struct therm this now instead. So in C, this has no special, it's just a keyword. It's just not a keyword, it's just a variable name. So now when I say return a dot value, I really say return this dot value. Right? Does that look more object-oriented to you? I didn't do anything different. The only thing that I did different is I named my variable different, my parameter different. When I call get value down here, though, there is a difference. When I call get value, I have to call get value on O. Because O is actually my object here. O dot value, I say get value on O. I cannot say O dot get value. But this is where I'm starting to get to the object-oriented programming side. The next step is that we want to be able to insert functions in here. So what I'm going to use, this is an int. This is going to be, oh boy, I don't remember. I haven't done a function pointer in C in fucking years. Yeah. That's not right. I don't remember the type to declare this as a function pointer. If you look at function pointers in C, let me go back. Let me see real quick. Yeah, that's the first one. Okay, yeah. So it is. So I was close. Okay. So it's going to be this. Star.
Yes.
That's what I was saying. You can text them.
So this here is a function pointer. That means that inside of my struct therm, there is an int value, and there's a thing that says there's a pointer to a function that returns an integer and takes a struct therm this as its object, or as its value, called get value. This get value and this get value over here are different get values. They're different things. So when I construct my object, let me go ahead and construct my object here for you guys. It looks something like this. So I say struct therm O. O is my object that I'm creating. I can say O.value equals 3, like so. And then I can say O.getValue equals getValue. Now this object O has a value 3 and has a function getValue called getValue. I know that's slightly confusing. I could change this value, this name over here, to make it more specific if you like. Put like an underscore in the front right here. So now I have this struct thing that has both the type and the function. If I want to now call getValue, I can say O.getValue on O. And this should look like the first step we got in Lua before we got the syntactic sugar. Any questions? Does that answer your question? Yeah?
Yeah, would we need a malloc anywhere inside this?
So the answer is the way it's written is no. However, the better answer is yes. And the reason why is because this getValue function does not take a pointer to this. So for example, if I wanted to change if I tried to change the value, if I said this dot value equals 0, when I call getValue on O, this O and this are not the same object because this is not a pointer. So to do that, what I would do is I would change this to a star, add a star there, and I would add a star there. And then I can do it by putting the ampersand here. However, this struct therm O exists only on the stack. And if whatever function this thing is in goes away, that object goes away as well. And if you don't want that object to go away when the function goes away, you have to malloc the space for that object before. Does that answer your question?
Yes.
Cool.
Okay, why did you get rid of getValue parentheses 0 for O.getValue equals getValue O.getValue? 0.
Say that one more time. Oh, this one over here?
No, the struct term 0.
Mm-hmm.
You originally had it 0.value equals 3.
Uh-huh.
And you had getValue parentheses 0
Uh-huh.
or O, and then now you changed it to 1.
Oh, so okay, so there's two, what's happening here is there's two different functions. So now I have this underscore guy here. There's this underscore getValue function, which I can call an O, right? Not 0, sorry, O. But this is just a function. It's not a function specific to this object. When I say O dot, not underscore, because O does not have an underscore getValue. O is one of these things. And it has a, this getValue there is the one that it has. On O, these are the same function call. But this is calling it from within that object, and this is calling the global function. Because here's the function. This is where I assign that function into that struct. They're the same thing. One of them is an object-oriented style, and one of them is the procedural style.
What if you didn't have the dash before the G?
So it's just the name. I just renamed this up here by putting the dash. If I took the dash away, then take the dash away. It's the same thing. It's just a name. It's just a naming convention. In languages where you don't necessarily you have a global function that you don't actually want people to call, you put an underscore in front of it.
So to make
Just
it object-oriented, you need the 0.get.
It's the O.getValue, correct.
You understand that? The O dot get makes sense.
This is the object-oriented style. Because when you're looking at, if you're thinking about it in terms of Java, for example, you say obj dot some function. Here we're saying O dot the function that I want to call. Does that answer your question?
Yes.
So this is also true. This should look like the when you're looking at, for example, in Lua, you have the O dot get value function in Lua. You have to pass in the self reference as the first object, or you could in Lua you could use the O colon, which is automatically going to pass the first thing as the reference. Other languages like Python and Java and C++ pass it in on automatically. Other questions? Yeah.
For the test, do we need to know all of that, or would you give us like one like?
So I'm not going to ask you to write this. This is maybe a little bit too far to ask you to write, particularly because we haven't done it in the lecture. But I am kind of asking you to understand the concept. And so the high-level concepts are objects are values and functions stuck together in the same data type. Those functions take non-primitive data types, which is itself as the first object, as the first argument, right? So that this argument is the first argument to the function get value. That's the only thing that separates it from an object-oriented versus a global procedure call, is that the non-primitive is the first argument as a pointer. Those pointers operate on objects of some kind.
You said they're functions and values stuck in the same. What did you say?
So they're functions that operate on non-primitive data types that are the first argument to that non-primitive data type.
Okay, when you was talking over here, you were describing what an object is.
So an object is values
A value.
or data and functions
That
operate on the object type.
okay.
If we want to look at what is C lacking, C is lacking the ability to call this guy get value on the object automatically. It's lacking inheritance. There's no way I can inherit from that struct over there. It's lacking polymorphism. There's no way I can override functions. It's lacking privacy. Everything is public inside of this struct there. Those are the things that we want, that you need to know. So like, which parts does C have? What things are object-oriented and what things are not? And so we talk about object-oriented programming. The fact that I can have a pointer to a non-primitive data type that returns something from that pointer is not inherently object-oriented programming. It's just procedural programming. Object-oriented programming is when we organize everything in terms of the non-primitive type. We allow ourselves to call it from the non-primitive type within itself. We have inheritance, we have polymorphism, we have protection mechanisms, or some semblance of those. And that's what C has and lacks. And that's why, what are we looking at when we're looking at C versus other languages? Does that answer your question?
Yes. I'm sorry.
No worries. Other questions?
Yeah, so I remember at one lecture you were talking about like this same thing, but you had like A and then you had O.
Mm-hmm.
So if you had like A dot get value of O.
So that was when we were doing Python, because Python supports this functionality as well.
Right.
Yeah, and it's the same concept.
So I guess in that case, will you get the value of A or O?
So if I had another struct therm A is what you're saying, right?
Yeah.
If I say A dot get value, that's horrible. A dot get value of O, I would be getting the value of O because O is the object that I passed in as the first parameter.
And so if I get this straight, A is like?
A would just be another object. So, and this is part of the problem that C does not support object-oriented programming because it doesn't automatically pass that A as the first object.
It gets this O.
Correct.
Right.
That's the whole point of that lecture.
But okay. And then because that lecture we're also discussing like inheriting.
Correct.
And like changing the what you get. So would you inherit the function of A then and just
so
take
you
the
would
value
inherit
for
the
O?
A's functions, but pass them to whatever O's values are. Yes, and that's because of the way that we did this call thing here. And that's the reason why we use things like Python or C++ or Java, because those languages do all of that work for us. We don't have to worry about A versus O versus types versus... I don't have to think about that crap. It just works, and that's what you want. That's part of the reason why people don't like Lua, because you have to do so much of the manual labor yourself and understand it. And if you don't understand what you're doing, you don't understand why you do a set meta table or how the index function works, you can't really get at the power of Lua.
So why do you think Lua is so cool then?
Because it gives you all of the power, and it also it's a good foil to test everything else against. So it's kind of like one of those things when I could show you Python as the first language, and we could be like, oh hey, look at all the really cool thing Python does, and we could use Python the entire class and never look back and do everything in Python. And Python would probably be your favorite programming language for the rest of the time, but that's not going to teach you about programming or programming languages or object-oriented programming, which is really what you need to know. Because understanding this concept here is important such that when you're using it in other languages, you don't ever have to do this again. I don't expect you ever to think about that ever again in the future. But knowing that you're calling some function on an object that is the first parameter, and I can do these kind of things, that's the important bit, because that's what object-oriented programming is. It's not magic. It's not pseudoscience. It's just fucking hard concepts of that crap.
Right.
That's all it is. Yeah.
Oh no, I was actually following something in there.
It's not magic. It's just hard. There are some things still that I say are magic. That Lua part that I said is still magic. That's fine. It's still magic for now. But give it another 2 or 3 years and come back and talk to me again, and I'll tell you what it really does and how we do it. Let this shit sink in for a little while. Other questions?
We do an object-oriented.
Sure, I'll do another one. So there's 2 answers. There's 2 ways to do a Lua object-oriented. What I'm going to do is I'm going to show you the generic method first without answering a question. And then we'll answer a question using both the generic and a specific implementation. Okay? All right. So the generic object-oriented programming in Lua is as follows. Object equals table. So in object-oriented programming in Lua, you have to have an object because the parents of any class is an object. So I create an object by making a table. Then I'm going to declare my constructor for that object. So function object (new), like so. I'm going to create inside of my constructor the things that you have to do in Lua is you have to create the object that you're going to be modifying. So I'll say obj equals table. That's the creation of the new object that you don't have to do in other programming languages. Then we're going to do the set meta table. Of obj to self. And this is allowing us to have inheritance with whatever class happens to be the one that we're constructing because of the self, not because of object. And then we're going to do the self underscore index equals self. And that tells us to use standard inheritance and polymorphism. Without this line, you don't get polymorphism or inheritance. You get kind of inheritance with this, but you get some weird shit going on. It'll look like it's working for most of it, and then something just randomly won't work anymore. You're like, what the fuck? That's the line that fixes it. And then you return the object. So this is the generic object-oriented programming. If at any point you say, hey, I need to make an object in Lua, if you start with this code, you're good. Let's answer a specific question using this generic code. So let's make a sphere objects. So if I want to be, so a sphere, and let's have the ability to get the volume of a sphere. So the sphere, for example, has what? What do spheres have?
Radius.
They have a radius, right? That's what will allow us to know the volume of a sphere. So to start in the generic fashion, sphere, I'm going to say sphere equals object (new). So now sphere is a new object. I'm not just doing so this is a generic implementation. We'll do the specific one afterwards. That's what you're going to see. That's why you're looking at me funny. Chill. So we have this, we don't want to use just a regular table because we want spheres to be objects. That's the way we're thinking about this. Currently, let's just write the volume function for now. Function, sphere, colon volume, and return pi 3.14. Probably has a pi inside of blue. I don't know what it is though. Times 4/3 radius cubed or something. 4/3 times radius cubed. So radius is, we're going to say self dot radius cubed. I don't know how to do that. Close enough. That'd go right there. If you don't know how to do cubed, you could also do self dot radius times self dot radius times self dot radius 3 times. That's also self dot radius. So that would be the volume of the sphere. What time is it? Just got to make sure I'm not.
2:18.
Okay, good. Plenty of time. Okay, so now the problem is, or not. There's not a problem. There is a problem, but we don't quite see it yet. I can say, for example, A equals sphere colon nu, like so. What's the problem with A? It's not that we don't. It's not that we don't know what it stands for. Sphere is a new object over here. I could say a dot get a dot a colon volume. Sorry, volume, and that would return the volume of the sphere, except.
Don't have to identify a type or something?
Don't have to do types inside of Fluid.
We didn't identify a radius?
There's no radius. So when I say a colon volume, when I say self dot radius in there, it's gonna say I don't know self dot radius. You haven't defined a self dot radius, because objects don't have a self dot radius or a radius at all. Spheres, however, will. So what I'm going to do is I'm going to define the constructor for spheres. Now, the constructor for spheres should do what?
Radius?
Take in the radius. And so we'll take an r, like so. And then we could do something along the lines of local obj equals the new table. We do these guys again. That's the self dot, the next line. And then before we return that new object, what do I want to do?
OBJ dot radius?
I want to set the radius for the new object. So I'll say obj dot radius equals r. Now when I call this constructor over here, I have to pass it a radius. So if I pass it the radius of 7, the radius of 7 will go in there. Now, have I saved myself any work over here by defining that generic object?
No.
Not quite. Now, there is a way that we can actually avoid doing all of that by calling the parent's constructor and some other stuff. But I'm not going to worry about that now. You don't have to worry about that now. If you want to spend some time figuring it out, go for it. All right, are there any short questions? Otherwise, I'm going to take a 5-minute break.
Short question. For the function sphere, does that technically take 2 parameters? Does the colon count as like a self?
Correct. The colon would be the first parameter, which is the self, and this would be the 2 parameter. The same way this is a 1 parameter function. The same way we had the 1 parameter function for get value with this.
So we're using call for R in the sphere volume.
So the R is passed in as an argument right here. which is this argument right there.
What is it called?
The self is the sphere.
Is there any reason why we can or we didn't?
I'm sorry?
Is there any reason why we couldn't or we didn't ask for it in the function sphere?
What do you mean? This volume up here?
Yeah.
Oh, because it's the idea is that spheres have volume. And so when you construct a sphere, it must have a volume.
Okay, is there a reason we didn't ask
You could have. Yeah, you could have done that.
No.
All right. I'll be back in about 5-10 minutes. I'm going to get some of the drink, and I'll answer more questions.
Top right.
Square button.
Ooh.
Yeah, square button.